Welcome to Lecture 3 Video， 欢迎来到我们第3次课程的影片。We will examine the fundamental building blocks used to construct computers. 我们呢，首先会检验这个很基础的建制的单元，叫做building blocks。它用来制作电脑、建立电脑的这个基础的单元。首先 ，how to represent and store information inside a computer。我们是怎么去呈现这个资讯，或者是储存这个资讯在这电脑里面呢？How to use the principles of symbolic logic to design gates？ 如何用这个所谓的符号逻辑来设计闸呢？ How to use gates to construct circuits that perform operations such as adding numbers, comparing numbers, and fetching instructions？ 我们会学到如何用闸来建制这个线路，这个线路呢，它会能够加数字、比较数字，还有抓取下一个的指令。So the first topic, binary numbering system， 二进位数字系统，或者说二元数字系统。First, let's see how we do the interaction with computer. Human beings use numbers, decimal numbers, with sign or with decimal points, or use words, English words, alphabets, Chinese words, and so on, using keyboard to communicate with the computer. Inside the computer, it only uses the binary number, the combination of 1 and 0 to store, to process them. To present the result, computer again will convert the binary to the decimal number, or to the alphabets, to the Chinese characters, and so on, back to the human being. First, let's review the base 10 numbering system, the numbering system we use in everything in daily activities. 我们首先来看看我们日常生活的10进位数字实际上是怎么运作的呢？ Each digit can be 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. 我们有10个数字从0到9，每一位数都可以是这样的一个数字的组合。So here we show a odometer as an example。在这里呢，显示一个里程的计数器来做一个范例。它是一个齿轮圆盘，上面有这些数字。那它转到9，每一位数转到9之后，下一个会转到0，然后带动左边的轮盘进位。Every position has its weighting values. We have the leftmost digit, it is 10 to the 4th power, and the digit next to it, the weighting is 10 to the 3rd, and keep going toward right, 向右呢，那我们到最右边的一位 rightmost digit, the weighting is 10 to the 0th power, it is 1. And the value of this the value of this base 10 number, it is the digit times the weighting. So the leftmost digit is 0. So we do the 0 times 10 to the 4th power. The digit to the right is 1 times 10 to the 3rd. And keep doing this until we reach to the rightmost digit. It's 1 times 10 to the 0th power. And when we do the addition, we got 1011. In this chapter, in some number, to avoid ambiguity, we will add 10 or 2 as the subscript. 我们为了避免一些混淆呢，在这一章的数字，我们有些会加一个下标，代表它的是10进位或者是2进位。Now, let's see the base 2 numbering system. Again, use this modified odometer as an example. 我们用这个修改过的里程计数器来作为我们的示范。Each digit can be 0 and 1. 当它转到1，下一个呢就是会再变成0，然后会进位。And we have a special name for binary digit. It is called bit. 中文是翻成位元。Values of positions, the weighting is power of 2. 是用2的幂次来代表。The left for this 5-digit binary number, 5-bit number, the leftmost digit, the weighting is 2 to the 4th power, and the rightmost digit is the weighting is 2 to the 0th power. So this 0, 1, 0, 1, 1. What is its value? Again, the same principle. Each digit times its corresponding weighting. So for the leftmost digit is 0 times 2 to the 4th power plus 1 times 2 to the 3rd power, and keep doing this until we reach to the rightmost digit. It is 1 times 2 to the 0th power, and it is 0 plus 8 plus 0 plus 2 plus 1, and the result is 11, base 10. And we call this procedure as binary to decimal algorithm. This is a table of binary to decimal conversion, and we list from 0 to 31. And we see the width of the digit getting wider and wider. 我们可以看到它的位数的宽度越来越宽。In particular, we see that the maximum number of 2-bit width is 1, 1 in binary, and the value is 3 in decimal. The maximum of 3-bit width binary number 1, 1, 1 is equivalent to 7 in decimal. Maximum of 4-bit width 1, 1, 1, 1 is equivalent to 15 in decimal. The maximum of 5-bit width 1, 1, 1, 1, 1 is equivalent to 31 in decimal. Then how do we do the reverse conversion? That is decimal to binary conversion. We will do the successive division. 我们会做连续的除法。Take the decimal integer and we divide it by 2. And the remainder is the first bit we get. And take the quotient. If it is still greater than 0, then we divide the quotient by 2, and the remainder will be the next bit. And continue this until we get the zero quotient. Let's see an example. 我们来看一个例子。19 in decimal. 19除以2，我们得到了商是9，然后余数是1。这个余数呢，就是我们得到的第一个位元。This quotient 9 is not 0 yet, so we will continue the division. 9除以2，这一次呢，商是4，余数是1。那这个余数呢，又是另外一个 bit. And the quotient is not 0 yet, and we do the division again. This time we get the quotient as 2 and remainder as 0. And we can continue this. The quotient 2 and do the division by 2. And we got quotient as 1 and remainder as 0. And do the last round. 1 divided by 2, and we get quotient as 0 and remainder as 1. And we get the final bit. All of the remainder combined can get the binary digits. And the leftmost bits is the last remainder. So we get 10011. And let's do the verification. Do the binary to decimal conversion and adding each weighting. 2 to the 4th plus 2 to the 1st plus 2 to the 0th. And it is 16 plus 2 plus 1, and it is indeed 19 base 10. Let's see max number of n bits. 在这里我们用这个5位数的这个5位元的2进位数呢，来示范如何来算它的最大的数值。Its maximum number for this 5-bit is 11111. Its value can be quickly calculated because it is a number before the 6-bit 100000, and it is the 6-bit leftmost digit weighting. 2 to the 5th power, it is 32. So 1 less than 32 is 31. 所以用这个方法可以很快的知道5位数都是1的情况下，它的数值是多少。因为我们知道它下一个呢，就是我们的里程计数器都要进位成100000. 当然在这里我们的计数器就爆表了。不过对于这个无限制的这个2进位数字来说，它的下一个数字的确是变成6进位的100000, 而这个呢是32， so 它的前一个数字就是31。 Let's do the verification, and we add all of the weighting. 16 plus 8 plus 4 plus 2 and plus 1, and it is indeed 31. 它真的是31。Largest unsigned whole number. 在这里我们讨论的是所谓的没有符号、没有正负号的整数。那它的最大数值是有限制、有上限的。In every computer, there is a maximum number of bits that can be used to store an integer. For 16-bit computer, or for a 16-bit system, the maximum number it can store is 2 to the 16th power minus 1。因为有16位数，最左位数是2的15次方。根据我们前面所提到的，要算它的值呢，就是取它的下一位数的 weighting 再减1。而这个呢是 65,535. For 32-bit, it is 4 billion, 超过4 billion. For 64-bit, it is a very huge number, and it is around 10 to the 19th power. It is a big numbers. Any operation that produces an unsigned value greater than the one listed above results in the error condition called arithmetic overflow. 假如任何的计算超过了目前架构下的最大整数的话，那我们就称它叫算术异位 overflow 称为异位。Now let's see the binary addition. 做二进位的加法。It is very simple. For each digit only have 4 possibilities, so we have 4 rules. 在每一位数的加法里面呢，每一位数的加法里面只有4种可能性 ：0 plus 0, 0 plus 1, 1 plus 0, or 1 plus 1。这4种可能性，而最后一种 1 plus 1 we will have a carry， 我们会得到一个进位。Now let's see an example. 4 plus 14 in decimal. 我们来看看它的二进位的加法会是怎么样来运作呢？ 7 is represented as 00111 in binary. 14 is represented as 01110 in binary. The conversions we have shown the conversion is we did the successive division. 用连续的除法可以转换出这些二进位的表示法。Let's do the rightmost digit first. 1 plus 0 we get 1. According to the rule number 3. And move to the next digit. 1 plus 1, we have a carry. For this digit, we have to add 3 of 1. We can do the first two. 先做前2个，再得到结果，再把第3个1加进去。Again, we got 1, 1. And next digit, and we have a 1 plus 0 plus 1. It is a 1, 0. The last digit is 1 plus 0 is 1. So we get 10101. And do the verification and do the conversion to the decimal. 16 is the leftmost digit's weighting. 16 plus 4 plus 1, and it is indeed 21. Now let's see other kinds of representation. After we finish our unsigned integer, we are going to see the signed integers. 这个有正负号的整数要怎么去表达呢？ For assigned numbers, the leftmost bit of a number as the sign bit. 我们可以用最左边的位元呢来作为正负号的标记。0 indicates it's positive. 1 indicates it's a negative. There are 2 forms, sign magnitude or 2's complement. We will choose 2's complement as our sign number representation， 用2的补数表示法呢，它的用途最广，也是目前最广为人使用的。Let's see what is the 2's complement. The leftmost digit, the weighting becomes negative. So it is a sign bit with a weighting. 最左边的位数呢，它变成是负的，不仅标记了这个正负之外，它的 weighting 本身也是有负的。So for this odometer example, 这个里程计数器的范例呢 11010 how is it goes? It is minus of 2 to the 4th power plus 2 to the 3rd power plus 0 plus 2 to the 1st power plus 0, and it is negative 6. To clearly see how the negative and positive number, we use this circular diagram for these 3-bit binary numbers. For the 8 of these 3-bit numbers, we write them down in clockwise fashion. 我们用顺时钟的方式写下这8个3位数的2进位数字。The right side number with the leading bit 0 is positive numbers. 右边的这3个数字，它的领头位数呢是0的，代表是正数。The left side numbers they are negative numbers because the leading bits are 1. 它们的领头位数是1，所以是负数，是负整数。And their corresponding decimal value are listed here. 你可以看到它是左右对称的 They are symmetric along the vertical line. And we also notice that there is one more negative number. 我们发现了有负的整数呢是多一个，比正数多一个。Then the subtraction is born. 有了这个负整数之后，减法就可以操作了。Let's see 3 plus negative 3. 3加上负3。根据前面的这个圆形图呢，我们知道负3是101， 3是011。我们来做这个加法。First digit we got 10. Second digit we got 10. The third digit we got also 10 with carry. Carry is discarded, so the result is 0. 我们把进位拿掉，所以结果的确是0。3加上负3的确是0。Let's see another example. 1 minus 3. It is actually 1 plus negative 3. It is 001 plus 101, and we got 110, and it is negative 2. So the result is consistent with the decimal representation. How do we distinguish a unsigned number and signed numbers? When we see 110, is it 6 or negative 2? 当我们看到110这样的一个3位数的时候，它到底是没有分正负号的6呢，还是负2呢？ A binary number stored in the memory of a computer takes on meaning only because it is used in a certain way. 我们只有当我们要用的时候，才会给它指定它的意义。所以，当你在记忆体看到一个110这样的一个2进位数字呢，其实你不知道它到底代表什么，甚至它可能不是代表数字，而是其他的含义。It is the context that determines the meaning of a binary number. 只有在使用的当下，它才会赋予这个二进位数字的含义。How to convert to the negative binary number？ 我们知道3是可以用这个连续除法得到011。那从前面的图表，我们知道-3是101，但是我们要怎么很快速的知道-3就是101呢？ How do we convert -3 to 101? Here we have a very quick algorithm to do this. First, do the bits inversion， 把每一位数都做0与1的互换，我们称为 inversion。1变成0， 1变成0， 0变成1。And we add 1， 再加1 we get 101。 This is the conversion from 3 to -3. Let's do the quick check. 101 using the signed integer algorithm. The leading bit is minus of 2 to the second power. And +0 +1, it is indeed -3. So this algorithm works. 所以这个演算法很好，没有问题。